Let's look at some examples of how to improve your designs by using the query language to generate design rules. Suppose we are interested in vias assigned to a certain net class. We can create a query to find these vias. We would like these holes to have a larger clearance to the power and ground planes on inner layers. If you generate a query, you can easily create a new design rule from that query using the Create Rule button. First, we need to select the type of rule. In our case, this will be a clearance rule. As you can see, the query is automatically used as the scope of the new rule. Now let's formulate the second query. The onMid keyword will be used to select elements assigned to GND and VDD nets on inner layers. Don't forget to use brackets to define priorities. If we set the clearance value to 0.2, we will see many rule violations appear in the PCB layout. These violations are due to the clearance between polygons and the vias. This is fixed by repouring the polygons. The next example comes from DFM. First, we can create a rule that limits clearance to the board edge. First, let's set the value to 0.4 millimeters. Obviously, the board was originally designed without considering this rule. So first, we update the polygons to eliminate several violations. There is a row of edge connector pins along the bottom edge of the board, and their location creates many board outline clearance rule violations. Let's use the FSO tool to create a query. We need to select all pads in component X1. Make sure to check the Create Expression checkbox, which will automatically compose the query from these conditions. After running the command, make sure you select the necessary objects. The text in the input field is created automatically. The Create Rule button then creates our board outline clearance rule. If you look in the Custom Query window, you will see the generated query expression. Now let's set the clearance to 0.2 millimeters, and then let's run a DRC check. With this rule, we created an expression for edge connector pads, allowing them to be closer to the edge of the board. Let's take a look at another example. Suppose we want to control gaps between 3D component bodies, and we need a minimum clearance of 0.5 millimeters. This is enforced with the component clearance rule. Inspection initially reveals multiple violations of this rule, which can be seen in 3D. However, we consider these violations acceptable, and we want to allow these components to be placed with reduced clearance. Let's compose a query that filters components based on their footprints. To do this, use the hasFootprint function and the OR operator to create combinations of footprints in a query. The footprint names can be copied from the Footprint section of the Properties panel. Let's set the allowed gap to 0.3 millimeters. A quick check reveals another violation between components, which we did not take into account. We can add this footprint to the query and use the OR operator in our filter. After creating the rule, make sure to check for any leftover violations.